Nicole.
And Miss Nelson. And today we're going to do constant rate of change in terms of distance equals rate times time. So this is still rate of change, but with this one, you guys have a very particular formula that we're going to use. This formula is actually given to you on your formula chart that you will get for STAR. And so we work it a little bit different than we've done all of our rate of changes up to this point. So, besides our distance equals rate times time, to help you understand that relationship a little bit better, they give you a triangle here to look at. So this line right here is pointing to what I'm highlighting in blue underneath the D, and that means that you are going to divide. And then obviously the X between the R and the T means that you are going to multiply. Okay, and that just tells you what operations you're going to do to be able to solve it. So if we come over here to the right, it says to find D, which is, and I'll actually come back over here on the left, D is distance, R is rate, and T is time. So that way when you hear me say distance, rate, and time, you're not wondering what I'm talking about. So now let's come back over here on the right. So to find the distance, okay, so the D, we are going to multiply the rate and the time, okay? So distance equals R times T. Now, when we switch it and we go to find one of the bottom pieces, to find the rate, we are going to divide, and we are going to divide the distance and the time. So rate equals distance divided by time. And if you want to write it D divided by T, that's fine as well. So just like when we find the R, to find the T, we're still going to divide. And this time it's going to be distance and rate. So time equals distance divided by rate, or distance divided by rate, okay, whichever you prefer. So let's get started with example number 1. It says an airplane flies at a constant rate of speed of 960 kilometers per hour. How far can it travel in 2 hours? So because it says how far, you know that that is going to be a distance. So I am looking for my distance right here. So that means a constant speed, because you have these 2 kilometers per hour, you know that that is your rate. And obviously your 2 hours, that is going to be your time. So my rate is 960 and my time is 2 hours. So I'm looking for distance. So distance equals R times T, which is going to equal 960 times 2. So come over here and do the side. 960 times 2, so 0, 12, 18, 19. So the distance is 1,920, and because you know that it's going to be kilometers, because of this piece right here where it said kilometers per hour, okay? So our distance is 1,920 kilometers.
Okay, number 1, a train travels at the same rate. The table below shows the travel times for Chattanooga Choo-Choo. They just want to make it tongue twisters for some reason. What is the average rate of speed? So let's look at our change in Y and our change in X. So we have a change here of plus 300 miles and a change here of plus 3 hours. So our distance is 300. It's like, oh, where'd it go? And our time is 3. So we're trying to find rate. So let's go back up here, and I'm going to go ahead and start with D equals RT, just because that is what is on your formula chart. And we're going to plug in what we know. So we have distance is 300. We don't know what the rate is, and our time is 3. So we have a one-step equation. We're going to divide both sides by 3. And remember, that's what Ms. Nelson said. Huh? Oh, R. And Ms. Nelson pointed out that I should put R, that's R that I'm looking for instead of T. I put the 3 was the T, not the R. Okay, so when we go back up here and look, we're dividing, remember, and that's what Ms. Nelson said when you're trying to find rate, D divided by R. Okay, so I'm dividing both sides by 3, that becomes a 1, 3 goes into 100, okay. 3 goes into 300, 100 times. So 100 is your rate. So the train was going 100 miles per hour. Yes. Okay, let's look. Ms. Nelson, we're discussing, we want y'all to try these on your own. Let's see what's on this page. 4, 5, 6, 7. You want to finish the first page and then have them try 4, 5, 6, and 7?
Yeah, that's good.
Okay.
Sorry guys, we were just trying to figure it out.
Yep. Okay.
Okay, so number 2 says the centipede moves 12 centimeters a minute. How many minutes will it take him to travel 192 centimeters? So how many minutes? So distance equals rate times time. How many minutes? So I know that I'm looking for time, so that's my question mark or my X here. My rate is going to be my 12, and my distance is going to be my 192. So I'm going to plug in what I know. 192 equals 12, and I'm going to leave a T in there so we know we're solving for time. So I'm going to divide both sides by 12. So 192 divided by 12. 12 goes into 19 once. 7, bring down the 2. 12 goes into 72 6 times, which zeroes me out. So 16 equals T, and I wanted to know how many minutes. So we need to say 16 minutes. And again, guys, once you know where the information goes, it's pretty easy to use. That's the only equation you're going to have to use when it's distance, rate, and time, and a combination of those.
Right. Sarah drove 688 miles and an average of 80 miles per hour. How long did it take her to drive that many miles? So how long, we know we're looking for time. So this is going to be our X. And it tells us that she went 688 miles and at 80 miles per hour. And we're looking for time. So let's do D equals RT. Plug in what you know. Distance is 688. And rate is 80. And we are looking for T, and I'm going to go ahead and use T. I'm showing that we are looking for time. One-step equation, guys. We're going to divide both sides by 80. I'm going to come down here and do 688 divided by 80. Let's see. 48, yeah, 8. 8 times 0 is 0. 8 times 8 is 64. Subtract. I'm going to put a decimal, bring down a 0. 6. 6 and 8 is 48. That goes, so we're finished. And we're going to count time equals, that's a terrible T. We're going to go with it, 8.6, and so remember we know what this is. It's time, and we were looking for hours. So it took her 8.6 hours to drive her 688 miles. Okay, page 2. Do you want to do the graph with them since we haven't done a graph yet? Just do 4?
Yeah, that's fine.
Okay, we're going to go ahead and do 4 since it's a graph and y'all haven't seen a graph on this yet.
Okay, it says the graph below shows the rainfall measured in a week. what is the average rainfall per day? Okay, so distance equals rate times time. Now, what I'm gonna do, guys, I'm gonna draw a table, because up to this point, we have always used tables to help us organize our information. So I'm gonna use the tables again to help, so X and Y, which means that this is days, and this is inches. Okay, so when I fill it in, all I'm gonna do is write the ordered pairs for these 4 spots. So in 1 day, it was 2 inches, 2 days, it was 4 inches, 3 days, it was 6, I'm gonna add 1 more, 4 days, it was 8, okay. So, the rate, so see, it wants to know what is the average rainfall per day. So we want the rate, so that's gonna be my X. So the time and the distance, so there's a couple of ways you can do this. What we're going to start by doing is finding my changes. So my X's, we're changing by 1. My inches, we're changing by 2. So using that information, I'm going to come over here and I'm going to plug it in. And so and you could also just do this right here, choose the first one. So distance. And this point, my distance is going to be the days. So it's going to be 1, and that's going to be my 2, And my time is going to be my 1 days. So when I set it up, distance equals, so 2 equals rate, which is R, and my time is 1. So to figure out what the rate is, divide by 1. 2 divided by 1 is still 2. So my R equals 2, and this is going to be in inches per day. So an increase at a rate of 2 inches per day. And again, if you didn't need the table, if you could look at the graph and know that I was counting up by 2s on my Y's here, and each day I increased by a 1, then you could also find your 2 inches in 1 day. So we would like you guys to go ahead and do the rest of these. You may or may not have a note check, so make sure you're fully prepared for that so that you can get your 100. Have a good day.
Bye.